Alright folks, hello. Give me a second to fix up my lights. Setup ran a little long. Alright, I got lights, got camera. Now, ready to get on with it. Now, first thing I wanted to do with you folks is talk a bit about, hello, Stefan. Talk to you guys a little bit about Photoshop again. I can turn this light off of my face. Alright, maybe I can just do a puppet as I'm talking to you guys. Alright, let's see. Going in... Okay, first of all, I'm going to stop doing that. Now, we're starting with 1-point perspective today. And the next two exercises, assignments we're doing in linear perspective is leading up to this assignment here. It's going to be a space that you draw based off of a postcard that I give you. You get to pick your own postcard out of a stack of them. And let's see if I have any examples of that. I probably should have found those first. Let's see what I have in the old students folder. Student work. Would that be in student work? Drawing. Not here. Great. All right. Well, I'll have that example for you next time. But in a nutshell, this is sort of it. If you can make out this postcard here, this is a painting by William Wegman. And he did a whole series of these postcard paintings. You see there's 2 postcards here, actually. Actually, maybe 3. I think I see another. I don't know. Either way, he filled in the space beyond the postcard. So, have that brewing in the back of your heads. What kind of crazy space you'd like to make. Because it has to match the perspective of the photograph or the postcard, but it can be whatever you dream up. Alright. Now let's get into the demo. I hope I'm still audible. Let's see here. Alright. Great, everybody's here. Ready to get started. But what we're doing today is just a basic introduction to perspective. Or linear perspective, rather. Whoa, I just realized this is going to be upside down for you guys. Let me see if I can quickly flip this. Let's see. Can I transform you? Rotate. Rotate 180 degrees. I did it! Alright. Great. So... let's get set up here. Alright, so you're going to need your ruler and use a range of ebony or of graphite pencils because there's going to be a lot of drafting work we do in order to just plot out the way before we make darker, more definitive marks. Alright. Yeah. Alright, let's center us up. I guess that's it, huh? Alright. So, let's talk about what linear perspective is in the first place. Linear perspective. First, the most important part of the linear perspective drawing is the horizon. So let's begin with the horizon here. Now, the reason why this is the most important part is because this is your eye level, meaning it's telling you your orientation in the space. Depending on how high up or down you're looking will depend on simply where the horizon line is. If it's at the bottom of the picture, we call that a worm's eye view, and it has the effect of just basically looking straight up. Right? So that's a tree. So you see we're looking up at mostly sky here. So conversely, if it's way down at the bottom of our page, oh damn it, I'm drawing all over the good sheet of paper I meant to, oh dang it, what a dummy I am. That's really inconvenient. Alright, anyhow, so when the horizon is towards the top of the picture, that has the implication that we're looking down. This is usually seen as a bird's eye view, so our tree can be more like so, and we more so be looking at the top of it, right? And then any kind of mountains would be way up here, and let's say we had a water feature, that would be right there. All right, now you can have as many vanishing points in a linear perspective drawing as you want. In a one-point perspective drawing, you can have a vanishing point for each object you add in if they're orientated differently from one another. Let me pull out an actual sheet of scratch paper. Silly jerk. Alright, now. So, now that's what the horizon line is. Let's talk about what the vanishing point is. If this is my sheet of paper, and let's just place the horizon line around the middle of the page. If I place one vanishing point on this horizon, then I'm able to plot out the receding sides of any object that's facing me. So we can turn this into train tracks, make an old timey railroad track scene. Now everything you draw needs to have some width to it, meaning there's never going to be something we draw with only one line. No thing like that exists in real life. Everything has some kind of volume to it. So everything you draw in these linear perspective drawings are going to have at least two edges. Alright, so perhaps alongside the railroad tracks we have a railroad station. So I could maybe begin by drawing like, I don't know, what's that deck that people stand on next to the railroad? We can say it's about that wide, and we want it to be parallel to the train tracks. So at the corners here and here, we're going to use the same vanishing point to trace out the receding edges of the train station. Now, wherever I decide to connect these two sides with a horizontal edge, that's going to be where my train station ends, the back side of it. Now, so we have this deck here. Let's make a building behind it. A good way to begin with these three-dimensional objects is to draw the let's say the square or vertical planes that are facing you. So let's say this is, and I'm doing this freehand, so it is going to look rather janky, but we're going fast. So imagine this is the, let's call it the side wall of it. Let's put a little door here. That's fine. And then maybe there's some stairs jutting out. We're going to use our vanishing point for that. And then the stairs come down this way. And every stair on it will recede toward, every step on it would recede towards that vanishing point. All right, so you get what I'm looking at here. So now in order to draw the receding sides, this is where my vanishing point comes in. Now, it's best to draw all the receding sides, even the ones that you don't plan on showing up in the final drawing, because it'll help us structure it in later steps. Alright, so I know I want the train station to sort of end here, or that vertical line to go there. Now, one thing I want you to notice is that we're basically drawing only 3 types of edges. Perfect horizontals, perfect verticals, and then the receding edges that all go back to this vanishing point. So keep that in mind. If you start getting lost in the weeds, remember that. You got your horizontals, you got your verticals, and you got your receding edges. Now, these are the ones that confuse people. So that's why I want you to develop the philosophy that your ruler is hinged to this vanishing point. It's stuck. It can only rotate around this axis. So when we're worrying about receding lines like the sides of the railroad or the sides of this building here, this shoddy freehand building, those edges are all going to recede back towards this horizon, or this vanishing point. So let's try drawing something that's not quite so janky. Let's draw like one of those, I don't know, water towers that would stand next to the railroad. So the reason why this is coming out so janky is because I'm not drawing very careful verticals and horizontals. The receding edges are easy to line up with your ruler, because we always know at least one side of that edge is going to be on the vanishing point. But you're going to have to take special care to keep your horizontals and your verticals straight. Alright, so again, let's draw the side of this water tower that's going to be facing us first. So you see how all these objects have to be parallel to one another, and with 1 point perspective, they basically all have to be facing you directly. Alright, so this is going to be the basic layout of my water tower. I'm going to have legs here and then some kind of cylindrical shape there, but first I have to feel out the volume of this box I'm going to build it into. So right now I only have one side. It's good for telling the width and the height, but not the depth. To get the depth, we have to connect the corners of this box to the vanishing point. And we can just imagine the lines stretching all the way back to that vanishing point. You don't have to draw the whole line receding all the way back to the vanishing point every time. I'm just doing this to help you understand where these lines are going. Now, this is all live, so you guys can ask questions in real time. Alright, so now I have this rectangle that's kind of zooming towards us from the horizon, and where we choose to cut it off at to create the back side is completely up to us. But we want it to kind of feel like a square in perspective. So we're going to feel it out just a bit. That feels like it's a square sitting down on that horizontal surface. So we're going to use that as the base of this water tower. Okay. So now we find the top edge simply by following a vertical, since that's one of the three types of edges I can have, all the way up, and wherever it intersects that potential diagonal right there, that becomes the end of this left side. Now we know where the back side of my box belongs, and so now I'm going to use a horizontal to plot out the final corner here. So where it intersects that receding edge, that becomes the final corner. And then I can connect these two. Now this kind of drafting work is where you would want to use your 2H or 4H pencils and draw really lightly. But I need for you guys to see this. So now I have a box that I can kind of build an object into. So let's say I wanted the legs of my water tower to be about this high. That would recede towards there. And then the cylindrical part to basically as tall as the rest of it. Well, first thing we would want to do is make this dissection here. So let's cut this box in two pieces. The horizontal cut is easy because notice on this front side we only have verticals and horizontals. That was true at our train station too, with exception to the stairs, but that itself can be built into a box of verticals and horizontals. And then notice every edge on this right side is either vertical or receding. All right? So deal with the front or conversely back side first because it's the most two-dimensionally flat. But wherever the corner of this side would follow the vanishing point and stop here, that would be the right-hand side of my water tower. And again, we want to draw careful verticals and horizontals. I'm just going to use a dotted line here because I don't know which part of this is actually going to be visible. And then there's where that part intersects the box, and then finally connect the two hanging corners here, and you have a little platform. We're going to talk about how to settle round geometric shapes, all manner of geometric shapes in the actual assignment that we're doing today, but for this quick demonstration, I'm just going to freehand it. Alright, so an oval would go in there, and then there's the drum, and then the legs could be just as simple as freehanding or using a ruler, better yet. The legs, so on, so on, and so forth. So I don't want to take up too much of your time farting around with this train station analogy. You kind of get the gist. So let me freehand the rest of that. So then you could make this look like a barrel. Have a little pipe sticking out of it. Now this little oval, even though I'm freehanding it, I know it's above the horizon, so I have to be looking up at the opening of the spout rather than down at the side of it. All right, great. Now finally, this is a pretty wide set of train tracks, but an array pattern that is receding away from you, like floor tiles, or in this case, railroad ties. There's a way to plot those out. Oh, dang it, I keep missing my dot. Let's put a little shadow on this side. So that's my rail, and this would be the side of it, right? That's my rail right there. Okay. Let's see. Now, I do have to make up the width of my first two railroad ties. So let's say the first one is about from here to there. Now, I can find the middle of this plane very easily if I exit out, meaning drawing diagonal lines from one corner of that rectangle to the opposite corner. This is going to be the basis of all of our shapes that we create. All right, more or less. So now we can connect the middle of this X to the vanishing point, and that gives us a fast midline for the whole railroad track shape. Come on now. There we go. Now once I have that, see, I have my first tie here. I have the middle point there. I can use the same principle as Xing out the plane to imagine another plane twice as deep as this one. Now that I know where this corner is, I can connect the corner of this initial plane with the center of that, and wherever this diagonal makes the connection with this left side, that becomes the new height of my next rail, or a railroad tie. And I can keep repeating that. So from this, now I have a new plane here. I can connect the corner of the plane to the center point, and I can continue to do that. You would find it gets super ridiculous the closer you get to the horizon. It gets exponentially thin. So I'm just going to show you the first few ties here and then move on. So the vanishing point and this Xing out of the planes technique can do a lot of the work for you. Right. So if you have any kind of repeating pattern like that, you can figure that out with this railroad tie technique. All right, moving on. My big dumbass. Now what we're doing today is called the 9-box problem. We're not creating a space yet. Really, we're just following a feature one step at a time. Now, the reason I want to tape this down really securely is that I'm going to use my T-square, and that's going to save a whole lot of time for me. Alright, so let me tape this down like so. for that is the way we use this T-square. If you're into carpentry, if you used a speed square before, it's the same principle. So we got the edge of our drawing board, and obviously we want to be careful and make sure that the edges of our page are parallel with the edges of our drawing board, which this is not because I just had to redo it, but close enough. But as long as it's taped down, we know that all my verticals and horizontals are going to be consistent with each other. So we just take the hanging lip of the T-square and just easily butt it up against the side here. And that allows me to do this and get a fast horizontal edge. So now the 9-box problem in a nutshell, where if this is our sheet of paper here, we're going to draw a horizon line right through the middle of the page. We're going to draw 9 boxes above the horizon, 9 boxes through the middle of the horizon, and 9 boxes in a bottom row, right? So this is the format of our 9-box problem. Let's get into it. So first things first, you want your horizon line to be in the very middle of your page, and I'm very sorry about this. You can't see my whole page. This is as high as I could get my camera. Oh well, take my word for it, this is the middle of my page, so we're gonna have to set some ground rules here for the camera, I guess. How wide is your view, Mr. Camera? You go from about, let's just say here for a safe zone, to about here. And then beautiful. Alright, so there's my drawing. You want yours to fill up your entire sheet of drawing paper. Alright, so the best way, again, is to just begin with my forward-facing flat sides, meaning the ones that are composed of only vertical lines and horizontal lines. Now these do not have to be all the same shape and size, but they can't overlap as boxes. Meaning, once I start filling out the perspective, I can't have the receding sides of this box passing behind the sides of my middle box. So that's going to be roughly the height of one. That's cutting it a little close. Get some space. And the same thing goes for our top row and our middle row. We don't want the two overlapping. Alright, close enough. And this one's going to be a great big giant box because I have the space for it. Well, how about just a wide box? Alright. So now I have the T-square butted up against the bottom edge of my drawing board. You want to make sure it's the drawing board and not the drawing pad, because the pages can shift around and give you wobbly results if you're using a T-square. Alright. So, as I'm doing this, I hope you're following along. This is going to be a boring, unedited video. Alright. So, how am I looking? I'm still on, Yeah. Alright, let's do the middle row. And as far as the vanishing point goes, you want that to be square in the middle of your horizon. That means it's going to be in the middle of the middle box. This is kind of problematic now that we mention it. This vertical line being so close to the vanishing point. We do not want that to be, or it's going to make our lives more difficult later. Now, if you don't have a T-square, here's how you can get consistent verticals and horizontals. You measure. My notches are all faded, so it does not have to be in so many inches. You can just do this. See? So you want to make sure that this corner is at the same height as wherever you place the other corner. It is paramount that you're careful and consistent with your verticals and horizontals, or everything we try and build into these boxes are going to be wobbly and difficult to make out for you, which should make this whole assignment hell for you. Okay, so we can do the same thing again from the side of the page. Now that we're pulling out a ruler, some students tend to get a little distracted by the notches on the ruler. Centimeters and inches don't mean a thing. In this universe, we only get by with our eyeballs. So it's far more useful to use this sort of custom measuring stick approach where you're drawing your lines on the ruler, drawing your notches. Alright, there you go. So you can see that takes quite a bit of time, but take my word for it, you need very consistent verticals and horizontals. So let's carry on with our T-square. Alright, oopsie. How's everybody's week going? Are we all staying well? I hope we're all staying inside. I'm enjoying it. Okay. And finally, let's do the bottom row so we can move on to the next steps. Bolt. Let's make a wide box down here. Now, feeling out the balance between having boxes that are so big that they overlap and boxes that are so small that it's difficult to draw shapes inside of them. You need to feel out that balance for yourself. But those are the two tolerances. If they're overlapping, you've drawn them too big, and if the second part of this assignment is too tight, too detail oriented, then perhaps your boxes are way too tiny. Alright, let's finish this one up. Alright, now we have to clean it up a little bit. We want to connect these corners that are disjointed. Whoops. Bear in mind that your pencil has width to it, so you can't line up your ruler right exactly on the edge. Got to back off it a little. And easy way to figure out how far is just to hold your pencil up to it. There we go. Now let's erase some of these stray lines. Now I tell you normally to be messy and sketchy. That's drawing from observation. With these kind of mathematic drafting based linear perspective drawings, neatness is key because there's going to be so many steps involved that if you're messy, you won't be able to see what you're working on after so many layers. Shut up, computer. Alright. Clean that up just a bit. Now, bear in mind, again, I'm drawing extra dark so that you're able to see it in the video. But this step here you would want to be doing with your 4H, 2H pencil, drawing as lightly as possible. This is all preparatory draft work leading up to more complex shapes. Now, let's turn these turkeys 3D. Now, this is the part where we start connecting the corners of my boxes. Whoopsie, too high. I have been staying busy, hard doing single working thing, let's do that thing, and the home thing. But I'm not sure how, but I am. Awesome. Super dadded up. Alright. So this is where we connect all of the corners. But instead of drawing them all the way to the vanishing point, which would create a lot of linear clutter, we're just going to kind of lightly sketch it. Again, making sure not to overlap or underlap the next box over. So again, we don't need the whole line, just as much as perhaps we're going to need. Now with these long edges, let's do these, or rather, these back edges that are actually being overlapped by the box itself. We're going to want to draw those in with dotted lines just so we keep track of which lines are the front side and which lines are for the back side. But you see, this line is fine. Shut up, Surrey. Nobody's talking to you. Alright, so now I have to determine where I want to cut off these receding lines, and I'm going to base it off of this edge. In other words, the inside edges of these forms, that's going to be the most narrow. So we're not going to want our narrow side to be this narrow, then it's going to be way too hard to draw things into that side. So nice and full, as long as it's not underlapped or overlapped by the next door box over. This is Good. Let me use my right here. So now I know the depth of my box. And it's a simple matter of connecting the edges now with perfect verticals and perfect horizontals. Now here's two more, I call them invisible edges, that if this box was completely opaque, these edges would be invisible. But since we need them to draft this stuff out, now here's the proof in the pudding. Now if these two corners don't line up on a perfect vertical, then I know I did something wrong, which they're not. So this edge is telling me that the back corner should be here. This edge is telling me the back corner should be here. That's a bit of a problem. So let me double check which ones. That looks good. It may be right here where I'm having to tip it on the clamp of my board. Let's see. Yeah, I believe that is the problem. So let's try this edge again. No, that one looks right. Well, maybe it's this one. I don't know. We gotta move on. Close enough. Alright, so once done, you really want to go back and clean it up. This kneaded eraser has had it. Alright, let's see. Thank you, messy backup eraser. Your methods are sloppy, but you get the job done. What a mess. This is also sketch paper rather than drawing paper. Alright, who is texting me? Is this one of you guys? That's Fernando. Yeah. Oh, this is a... Alright. That was a personal question about grades, so... Alright, moving on. So that's what we're doing for each of these. We're turning them into boxes, hence the name, the 9-box problem. So, hope you're all working with me, because this is unedited. Okay, so let's do that. Let's just play with the diagonals now while I'm at it. So I know I don't want this box to go any further than that. Okay. I'm going to do this middle box last because its lines are going to look like extensions of all the other diagonals. So, you can see how you can start to intuitively sense if your boxes are going to overlap or not, and you can stop short accordingly. Another thing we don't want to happen is for the edges of our box, of any one box, to overlap. Like for instance, let's see, if I made this one approximately about this deep, then where the horizontals will connect to this back edge are going to be right here on the same axis as my front edge. That's going to be way too much trouble. So you want to make sure not to do that. As you're feeling out the back end of your boxes, if that happens, you're just going to have to change the vertical axis. So let's forget about that one. And those. Alright, back to chipping away at these diagonals. Any questions so far? We're all good? This is basic stuff. It should feel basic because this is just the preparatory work for the actual assignment. Remember to use dotted lines. It'll save your eyes. This can be disorientating for some, because in this kind of this sober and sterile black and white straight edge environment, we can lose sight of what's coming or going, what's advancing or receding, and you can get some weird projections in your imagination. So, using these dotted lines becomes necessary just so that you don't get disoriented in your own drawing. One thing, you want to put faith in the vanishing point. If this drawing gets screwed up, it's going to be at the verticals and horizontals. All of these receding lines should be a no-brainer. Just connect it to the vanishing point. Let the vanishing point do the heavy lifting. Which is why when we get into two-point perspective, it actually is going to seem a little easier. Alright, so now let's do my final one. This one has the potential to be the most disorienting box of them all, because all the receding edges are invisible edges. Alright, that does that. Let's now connect all these boxes together with horizontals and verticals. Let's start with our verticals. Oops, dotted line. Okay, so we can only get started. Oh, that's a crooked line. Great. We can only get started with one back edge at a time. If you try and connect both of these verticals, then they're going to be out of alignment with one another. We let, for instance, now the horizontals that extend out from this side, we let that determine the placement of the other corners. What am I doing? See, I'm getting disoriented. But because it was a dotted line, I realized what I was doing. Because if this corner goes here, we know the other corner is going to be somewhere around there. So this whole section doesn't even need to be there. And then finally, the fact-checking line. If these two corners connect on the same axis, close enough. Close enough and cleaned it up. Oh, wow, what a filthy cleanup job this is. Alright, moving on. Produce and fancy free. I'm ready for the big time as a ready for me. So you see, rather than kind of assembly line each box with all the verticals and horizontals, I'm realizing now that it's actually easiest just to knock all of the edges out, alternating between horizontal and vertical. Alright, we'll do the cleanup afterward. So, these broadcasts are archived and posted on the main page of the channel after YouTube processes them. So these are half-hour, hour-long streams. So that's going to take quite a few minutes for YouTube to process through and then to post in an archived format. So if you're looking for this video on the channel page immediately after the broadcast, you won't find it. Gotta be patient. Dirty pig up. Good job. At least I know which lines aren't supposed to be there because they're the smudgy ones. So again, for your own sake, draw lightly. Okay. So when you're lining up these edges with your ruler, make sure you put your eyeball right over the point where the mark is beginning. Sorry to block your view, but I gotta get my eyeball in hover mode. Oh, great. Close enough. All right. So you see I'm dealing with this back edge most often, meaning we are to understand that this edge is the closest one to us, and conversely that one's the furthest edge or corner edge, furthest edge from us. So notice how I'm beginning with this one, so I make sure that this edge or that edge doesn't overlap this edge. So for instance, I'm starting on this side, not on that side, because this is the edge that runs the risk of being overlapped. So just by beginning with it, I nip that problem in the bud. Almost there. Entertaining workshop. Why does I feel like a dancing bear? Uh-oh. Uh-oh. Did I do it? What? What a janky box this is. I really think it's because of these. See, it's because of this. But we gotta work on the fly here. But you can see how crooked boxes are gonna be a great big pain in your butt. Alright, well, we're not going to end up using every box. You do have some extra boxes. Now, I'm setting a bad example. Let's pretend I drew that one well, alright? It's a demo. We're moving on. Because you do have to draw all of your boxes correctly, even though we won't be filling them all. Let's talk about the shapes we're going to be building inside these boxes. There is the pyramid. Let's start with the pyramid. How does one spell pyramid? Yeah. And there is the prism. Right. Let's see. Then let's just call it the diagonal box. It's just a box balanced on its edge. Alright. Let's see, there is the cone. Is it time for the cone? Let's see, these might move around. Cone, cylinder. I never know how to spell cylinder. Cylinder. Hey Siri! Hey Siri! How do you spell cylinder?
Cylinder. C-Y-L-I-N-D.
Alright, shut up. Alright. Cylinder. Let's see. There is the T. Is it the T? Yeah, let's just say the T. 3D T. That's what we're going to do. The T. And then finally, the 3-step stairs. And it has to be 3 because it teaches how to deal with odd numbers. All right, let's begin. Now again, remember, all of this hinges on the technique of Xing out your planes. So beginning with the pyramid, we're going to want our the triangles of our pyramids to be on the receding edge, not on the front edge, because it would be all too easy to divide this perfect horizontal in half just by measuring it out, right? And dividing it in two. The trick is knowing where to divide this one in half, because if we were to eyeball it or freehand it, then what we eyeball, I'm going to say that is the halfway point. But if I X out the plane to find where the true foreshortened halfway point is, you're going to find that it's, whoa. See, it's back a bit more than that initial mark. So let's begin that way by Xing out this plane. I should probably make this edge a little darker. Alright. Now, again, this is drafting work, so we don't want to be too heavy-handed. Oh, you know what? I'm thinking we're doing the prism. I'm such a dummy-dummy. Alright, forget it. We're not Xing out the side plane, we're Xing out the top plane. Because after all, what is a pyramid? A square bottom, a pointy top, and 4 triangular sides. So we already have our rectangular or square bottom. What we're trying to find is the pointy top. Alright, so there the peak of my pyramid shall be. So like I said, we already have our square, so now it's as simple. Let me get a marker to do this part. Because this is the part that matters, the shape that we're building inside. So we already said that this is the base of my pyramid, so let's go ahead and darken that. Oh no. Are you dying on me? You are. Alright, forget it. I'll just draw extra heavy-handed. Doesn't look much different, does it? Hey, Sydney. Yeah? Come here. Do you know where my red felt tip pen is? You know that I was grading with and you took the draw? Can you go find that?
Yep.
Thank you.
Right here.
Thank you very much.
What's you drawing?
Drawing shapes in the boxes now.
I wish we could use the other computer for Prodigy.
Okay, well, this is class time now, Miss Sid. Do you have a, look, this thing is dying. Do you have a black marker that works like that?
I have a Sharpie.
I need a fine-tipped one. Don't you have small Sharpies or skinny Sharpies?
Well, yeah.
Okay. Anyhow, let's just. It's not that important with the pyramid. You get the gist. Connect the four corners with the top point there.
I have this and I have to find it.
Beautiful. Thank you. Wow. Heavy duty. Alright, thank you.
I need to go.
Can you do that upstairs?
I'm right here.
So it's not in the background?
Oh. Oh, I was about to turn.
And even with your shapes we're building inside, let's use dotted lines to denote the far side of them. Alright, next is the prism. So what is a prism? It's a square or rectangular bottom, two triangles on either side, whoopsie, and then a horizontal line connecting them. Meaning we want our triangles to be on the receding side. As mentioned before, you get it, blah, blah, blah. Alright, here we go. So let's X out both side planes. Hey Sydney, can you close the door?
Yeah. And if you.
No. Okay, so now that I have those X'd out, I can draw a vertical through the middle of that X. And this is just a guideline to figure out where the peak of my equilateral triangles are going to be. And that's wherever this vertical line intersects the receding edge of the box, right about there. Now, drawing our prism is going to be as simple as connecting the dots to draw a triangle on both sides. And the dots we're connecting are the two corners and that middle point right here. So let's start by drawing the base, since we know nothing is overlapping it. We can just draw those with nice, straight, bold lines. Okay, so got the base. Now let's connect the three corners of my triangles. So you can start to see, let's draw this vertical line, what these shapes are good for. This is good for roofs, tents, I guess. Whereas the pyramid, that'd be well suited for like towers. So that in a nutshell is the assignment we're working up to. Yes, it's going to have those postcards in, oh shoot, you know what, I realize we're not going to be on campus to hand out postcards. Nuts and nuts and nuts. So I guess we're all going to have to dig up our own postcard images. They have to have a full scale of depth, meaning we need to be able to see. It's got to be some kind of exterior scene with the horizon clearly visible so that we can reverse engineer it and it has to have at least one piece of man-made structure or architecture. So it needs to have a house or a bridge or something that's made out of right angles and flat sides so that we can figure out the linear perspective from it. So let's see, we'll figure that out next time when we're doing the two-dimensional or the two-point perspective version of this same assignment. All right, so this is what you guys get to work on over the weekend, and on Tuesday we're going to get back into the same thing with the two-point perspective version. Now, there's your prism. Let's do the diagonal box, which is just going to be like the prism in that the shape we're figuring out is going to be on these receding sides. But we figure it out the exact same way as the prism by Xing out the side planes. So X out both of these receding planes. Alright, so remember the whole point of Xing out the plane is so that we can find our midpoints, or midway points on the edge. Now we do need it on the top and bottom this time, not just on the top like with the prism. And on top of that, dang it, missed. Alright, not only that, but we want to know the halfway points here and here, which, yeah, we could go through the trouble of measuring that and trying to divide it in half. But again, let the vanishing point do the legwork. We already figured out this center point to that plane. If I line up my vanishing point with that center point, then that receding edge will show me, whoops, first it's got to go through the center point. It'll show me where those halfway points belong. So this is a moment when our vanishing point can save a lot of time for us. So again, put your faith in the vanishing point. Great. Now we have these cardinal directions on our planes. Oops. Like right here, right there, right there, and right there. So we're going to connect those to make a diamond shape. Now I am pretty much drawing from top to bottom, left to right in these boxes. That may not be the best idea. We'll talk about that in a minute once I finish this box. Okay, and that will connect to that. So again, just like with the prism, we draw the same shape on both sides of this box. And from center point to center point. And from corner to corner. Finally, let's do these invisible sides. All right, now, as I was saying, these are going to get more and more difficult as we go down the list. So for these two, the most difficult ones, we're going to want to save one of these boxes at the corners or at the sides. This one's going to be the most tricky to draw something inside of, and the ones in the middle aisles, they might be a little tricky as well. So let's move on to the cone. Like the pyramid, except we have to figure out how to draw an ellipse at the bottom. So the way to do that is to, of course, first start with Xing out our plane. But let's imagine taking this bottom plane and reorientating it or turning it in space until it's flat in front of our face, like that. So we can get a nice 2D look at it. So again, we would start by Xing out our plane, but like the diagonal box, that's in order to find my cardinal directions, because at these 4 points, these are the only points where the ellipse would actually be touching the frame around here. So the thing with ellipses is we gotta sketch them in. There's no straight edge that'll help us do this. We have to just do it to the best of our ability. So we can feel out these kind of semicircular notches here. Again, these are the only points where the ellipse connects the outside edge, and then we just kind of fill in the gaps. Now, two things we want to avoid. We want to avoid flat tires, meaning ellipses that hug the sides of the box for too long. There's no hugging, only kissing. We just want these edges to just kiss that middle cardinal point. We don't want it to get too kind of mashed along the side. We also want to avoid, are you seeing that or am I overlapping that? We also want to avoid diamond-shaped ellipses, meaning we're cutting too quickly. If you can see that, let me try and draw that right-handed. We're cutting too quickly from point to point, right? So, ellipses are going to be tricky for that reason. So let's build it into this one. So again, we X out the top, or rather the bottom plane. So you can see how tricky it gets once we're dealing with a receding plane. Alright, and again, the whole reason we're Xing out this plane, is to find this middle point. We want to line that up with the vanishing point. That'll quickly show us our halfway points on the front and back sides. Right here and right here. So right about there. And then we can use our horizontal edge to figure out those cardinal points to the right and left sides. So there's my cardinal points. Let's highlight them. Alright, now comes the time where we do those little semicircular curves. You can see in the tight corners and the acute corners they're going to have to curl considerably, but you still want to try and get them into those corners. And with the flatter edges, again, you're going to want to make sure that they fill the corners in the same way. Okay, that means that And every single one of these corners of that bottom box, this is sloppy, sloppy, sloppy. Ugh. Doing all this with an ebony pencil. Alright. So in other words, in this kind of arrowhead corner here, we want to feel like there's the same amount of surface area in every corner. So does that feel like the same amount of surface area? Yeah, it's receding a bit. So it's a little smaller, but it still feels like the same shape in the same area. Alright, and then finally, well, we want to X out our top plane to figure out where the tip of this cone is going. Alright, so there's my center point or my middle point. Now, like the vanishing point, we want to kind of pivot our ruler on this point, and the first sign of our lips we see peek out from underneath the ruler, that's where we want to begin the side of our cone. Same case here. That's a cone. So our cylinder is probably going to be easier to make out because this box is quite a bit more, bit larger and a bit more open at the sides. But it is going to be an elongated kind of oval shaped cylinder. Alright, so let's get to Xing out our planes. So you can see that Xing out these planes is great for giving us halves, for dividing our planes into halves. The next couple of shapes, though, are going to show you how to chop your shapes or your boxes into quarters and into thirds. Alright, so there's my center points. Use those to find my cardinal points. I need to sharpen this pencil. That'll make my job a little easier. Alright. There we go. Right there. And right there. Highlight those points. Line the vanishing point up with this center point, the middle of the X. And this receding line will show me, again, my back midpoint, my front midpoint. Now let's use our horizontals to do the same for my left and right sides. Right there, and right there. Alright, got my cardinal points. Let's highlight them so you can see them. Let's see. 1, 2, where are you going? 3, 4, 5, 6, 7, 8. Alright, so let's begin by drawing the ellipses, or rather sketching them out. So again, there's going to be rapidly curving sides of that ellipse and straighter, more obtuse sides. And of course, they're going to concur with how obtuse or acute the corner is. So we really want to make sure that we're filling in those acute corners. Those are the easy ones to shortcut and create a diamond-shaped ellipse. The obtuse ones are a little easier because it's a bit more of a straight shot. Alright, so that's good. Alright, again, make sure you're filling in those acute corners. Make sure we're not hugging the sides though. Remember, no hugging, only kissing those sides. Just touch it for a second. Alright, so sketch that out. Now carefully, oh shoot, blocking it in. Oh shoot, sloppy, sloppy. Ugly. You fail, Steve. Okay. Forget I'm supposed to be. Oof. Woof. Alright, and then finally we just connect the extreme outsides of these ellipses together to get our cylinder. Ta-da! Okay, great. Finally, we got the 3D T and the 3 stair steps. Alright, I'm going to make my T in this middle one because I want to save this easier box for my 3 stair steps, or 3 step stairs. This is going to be tricky. So tricky. I really wish I did this one better. Oh boy. Let me fix up this ugly guy. Alright, let's fix that problem. Nah. So, what's it connecting here? It's better. I declare does. Alright, moving on. So we want to draw the T shape on the receding sides again. So we're going to need to quarter up our sides. Let's cut them in half, like so. And this is in order to get the cardinal points. Whoops. We also want to do that for this far side too. Now sometimes you can let these X's do some of the work for you when it comes to projecting the shape from one side to the other. So let's start it on this wider side. Remember, we want to get those cardinal points, but let's not draw. Actually, I think we might need to. So once you get these cardinal points here, do that a little bit, yeah. And this cardinal line there. Alright, now this allows us to chop these halves into half. So you can see it's a lot like the diamond box we drew earlier, in that we're pretty much exactly drawing that shape, but it's more like I'm Xing out each of these, each of the 4 smaller rectangles we made by drawing out the cardinal directions. So in doing that, I'm finding my quarter points, right? We began with that initial X, and now all we need to draw is the counter diagonals, because this time what we're after is not the cardinal points, but these points, these quarter points. We could essentially draw a box that's half as big as the original side through this method. All right, so now if you're careful with your horizontals, you can project this shape over to the opposite side with some carefully laid out horizontals. So if you have a T-square, you might be able to save some time, because wherever this point connects on a horizontal axis with the X here, you see we're just projecting this point on this original X to the other side, so wherever it intersects, we can save some time that way. Though if you don't have a T-square, I would advise you just to, cardinal out and then quarter out that other side. But we can save us forward time here. There's the other one. There's that one. And that one. So now that we have these quarter points, we can then draw the T shape with verticals, which if all your box was originally built well, then you'd find a vertical would line up these 2 points. All right, and then we can line up our vanishing point with the armpits of our T to find where the arms are going. Right? So you see the overall T shape. Let's draw those edges that, well, I'm getting ahead of myself. And likewise, just like with these points on the X, you can find the foot of the T on the opposite side just by lining up this point on a well plotted out horizontal over to its mirror edge here. So that should be all the points I need. Well, there's the arms of the T, but I think always trust the vanishing point over your own verticals and horizontals. The horizontals and verticals, those are the wild variables, the wild card variables in this little experiment. The vanishing point is the anchor of this whole picture. All right. So you can see the T shape we're going for. Alright, now let's connect the arms of our T across like so. Draw this top plane. Oh, I missed my mark. Klutz. All right, and so this edge ends here. Let's connect the foot here. And there you go. If you want it to be super, well, yeah, I do want you to be super technical about it. Let's draw the back side of this T with dotted lines. That goes all the way up to here. Alright, so no questions on. Alright, final, last but not least, the 3-step stairs. We're going to want them to be coming right towards us, like we're about to climb up the stairs. So that's going to require us to have to figure out a zigzag pattern on the sides of this box. So let's do it on the far side because it's quite a bit more open than this inner side. Alright. So, what we're going to want to do in order to figure out how to draw a stair pattern, well, 3 steps, is to work out a tic-tac-toe pattern on this diagonal side, right? So, we're not going to be able to do that with an X alone, but it will require the X. So how do you figure out how to divide thirds along this receding edge? Because if we X it out, that helps me figure out where the midway parts are, the halfway points vertically, but how do I translate that into thirds? I was able to translate that into quarters, but the conversion doesn't make sense here. So when in doubt, go with one of your... Oh no, you jerk. Ugh. Great, just great. Well, my camera crapped out on me, so we'll just have to pick this up where we left off on Tuesday. I'll see you guys later. do I stop streaming? Alright, bye bye. Hit me up with an email if you're confused about something.